Hello and welcome to your favorite YouTube channel Shridevi Classes, where we inculcate confidence and interest in science and engineering subjects. Today in our playlist Class 12th Physics, we are dealing with subject electrostatics and will study superposition theorem, where we will find resultant force on a charge by the presence of several charges, and we will also study equilibrium of three collinear charges using superposition theorem. Let's start. 2-point charges Q1 and Q2 at a separation d in a media of dielectric constant epsilon r have electrostatic Coulomb force given by this formula K Q1 Q2 upon epsilon r d square. We have to increase this force on first charge by second charge or force on second charge by first charge by placement of either positive or negative charge either in between or to any side of these charges. And the logic is that force between two charges is a solo interaction of these two charges only, and it will not depend on position, polarity or magnitude of any other charge. And this fact is solo base of superposition theorem. According to superposition theorem, the total force on this plus q charge by the presence of these q1, q2, q3 and q4 charge is the vector sum of all individual forces F1 produced by q1 only, F2 produced by q2 only, F3 produced by q3 only and F4 produced by q4. So mathematically total force is vector sum of individual forces which are obtained by considering only one charge in action at a time. So F1 is a force of q1, F2 is a force of q2 and F3, F4 are forces of q3 and q4, and these individual forces F1, F2, F3, F4 vectorially when added up will result in a force which is resultant force due to the presence of all these four charges on this plus q charge. We have to find out condition of equilibrium or zero resultant force condition on a charge configuration of three charges when resultant force on any charge by the presence of several charges is zero, or all forces will act to neutralize resultant effect, then that charge will remain in equilibrium at that particular position continuously. For a charge configuration of three number of charges, there are certain conditions for equilibrium of all three charges. All three charges are on one line. They must be collinear so that force on any charge by other two charges will come on the same line and opposite in direction to neutralize each other, so every charge could remain in equilibrium. Two corner charges as marked in red ellipse should have polarity opposite to that of central charge, so that either both corner charge attract it or repel it in opposite directions to neutralize each other's force effect. And this central charge of blue ellipse will produce a force opposite to the corner charge on other corner charge force as shown here. If two corner charges have different magnitudes, then the center charge should be placed closer to smaller magnitude so that attraction force by smaller charge at smaller distance get equated to attraction force of bigger charge. And likewise, this middle charge should have least magnitude among all three so that force of repulsion between corner charges get balanced by smaller magnitude middle charge placed closer to this corner charge. We will understand that if these two charges have a ratio of 1:m, then the spacing will have a ratio of 1:√m, and this middle charge would have a magnitude m upon 1 plus root m square q, which is least among all three. Two charges plus q and plus mq are placed at a separation of capital D distance. We have to find out magnitude, polarity and position of this third charge on same line so that this system of three charges remains in equilibrium. So they should be on the same line. So the third charge should be on the same line, and for like polarity, positive of corner charges, it should have negative polarity. And if this m is greater than 1, then its position would be nearer to this smaller magnitude and it should be of least magnitude. Let this central charge got a magnitude negative polarity small q, and it is placed at a distance small d from plus q charge on joining line in central position. positions, and to find out its position we have to find out equilibrium condition on this central charge, because that equilibrium relation without knowing the magnitude of this central charge can give us value of this small d. This central charge will have attraction force from both opposite polarity charges. This A charge have Fa attraction and this C charge have Fc attraction, and both force are equal and opposite, so resultant force will become 0 with this condition. This is force due to A charge of capital Q at small d distance, and this is force by mq charge which is at distance d minus small d. Now this small q, k and this capital Q get cancel over, and the ratio of two distances, this small d and the remaining d minus d square, got a ratio of m is to 1. So two distance d and capital D minus small d got a ratio as shown by this yellow highlight. So if this distance is d, then this distance would be root md, and we will make total 1 plus root m part of capital D, and the smaller part d will be obtained by this relation. And this position of small d is independent of small q, and it only depends upon the ratio of two corner charges, that is m. So by equilibrium condition of force on central charge, we have obtained position of this central charge as a ratio of this total distance 1 is to root m. And now the magnitude of this small q can be obtained by equilibrium condition on either of corner charge A or C. Let's use equilibrium condition of charge at position A. Now this charge of A position get repelled by identical position corner charge by a force of Fc, and get attracted by central charge of opposite polarity by Fb force. And if two forces are equal and opposite, then equation of force equilibrium is this. This is force by small q charge, and this is force by capital mq charge on capital Q at a distance small d and capital D. When this d square is shifted to another side and k and capital Q get cancel out, we got that small q here is given in terms of capital Q by this relation, and we know capital D is 1 plus root m times small d, and if that value is substituted, we got small q in terms of capital Q as multiplied by m upon 1 plus root m square. And if this m is a square number, then this figure is easy to remember figure. And one important thing, this central charge got a polarity opposite to two corner charges. If corner charges are of positive polarity, center charge should be of negative polarity, and otherwise corner charges are of negative polarity, we have to use positive central charge. 2 point charges plus q charge and plus 9q charge are spaced 60 cm apart, and where and how much charge should be placed so that this system of three charges, these two charges along with the third charge, remains in equilibrium. So we have to place that third charge on the same line with opposite polarity and least magnitude, and since this plus q charge is smaller than 9q charge, the position of this center charge should be closer to plus q charge. Now to find out position and charge magnitude, first we will find out equilibrium condition of central charge so as to get the position first. And capital Q have a force by small q charge at a distance d given by this relation, and similarly capital Q have an attractive force in opposite direction to previous force by 9q charge at a distance 60 minus d centimeter. Here when we write relation, we use this d in centimeter, and for meter conversion the 10 to the power minus 4 in denominator at both sides will get cancel over, so there is no need to write that centimeter to meter conversion. And now the final answer of d will also come in centimeter. Now k, small q and capital Q get cancel over at both sides, and when side is changed, the 60 minus d whole square and d square ratio comes as ratio of two charges 9q and q, which is 9 only. And since 9 is a square number, so when we take square root, 16 minus d over d get a ratio of 3. So this division of 60 centimeter in 1:3 ratio will make 4 parts. So 1/4 part of 60 centimeter is d. So position of minus q charge is at 15 centimeter from smaller charge and 45 centimeter from bigger magnitude charge. So we have obtained for 9q charge amount, this position of center charge got a ratio of 1:3. So small d is capital D by 4 in our example. And now we can find out magnitude of this central charge. And for that we have to find out equilibrium condition on this corner charge, and on small q the force of attraction by capital Q at a distance small d is given by this relation, and repulsive force by other corner charge of 9q at capital D distance is given by this relation. And equilibrium means two forces are equal and opposite, and here kq will get cancelled out, and capital Q in terms of 9q other charge got a ratio small d to capital D, and small d is 1/4 of capital D. So this is 9q by 16. Easy to remember figure. This 9 is a square number and this 16 is next square number. And one important thing, this central charge got opposite polarity, so in fact it is minus 9q by 16. In objective nature examination, question on such three charge system equilibrium are frequently asked, and if this is capital Q, this is m times capital Q, then this central charge of opposite polarity have a position 1:√m ratio, and small d is capital D divided by 1 plus root m, and its magnitude is m divided by 1 plus root m square capital Q with opposite polarity sign. And we have seen that when m was 9, this distance is 1/4 of capital D, and this value is 9 by 16 times of capital Q with opposite polarity. Similarly, when charge are q and 4q, m is 4, then this ratio 1:√m become 1:2, and the total 60 centimeter should be divided in 3 parts. So this separation is now 60 by 3, 20 centimeter, and the second part is 40 centimeter, and this magnitude is 4 by next square number is 9, q with opposite polarity. Similarly, for q and 16q condition, the ratio 1:√m is 1:4, and we have to make total 5 part of 60. So this one part is 12 centimeter and the remaining part is 48 centimeter, and this magnitude is 16q divided by next square number 25 with opposite polarity, and for 25q the ratio is 1:5, and 60 centimeter got 6 ratio, 10 centimeter 50 centimeter, and the magnitude is m 25 next square number 36 with negative sign. Hopefully now you understand what is superposition theorem in electrostatics and how we can apply that theorem to find out resultant force on a charge by the presence of several charges near to it. With the practice of given examples, you can now face all examination questions of superposition theorem and can determine condition of equilibrium for 3 collinear charges. If you found our study material valuable, do share it with your friends. And to get more from our channel, do join YouTube membership of Shridevi classes. Definitely after membership, when you receive online class support and study notes from our channel, you will get high scores in your examinations. Thanks once again for all sort of support and confidence in our channel.